Okay, now if you if a polynomial looks like this, it's got an x minus some number, an x minus some other number raised to some power, and an x minus some other number, and then a bunch of other stuff, okay? It's going to have 0 at x equals a, because a minus a is 0, and multiply that out. It's going to have 0 at x equals b, and at x equals c. The 0 at x equals b is said to have multiplicity p, because that's the power of this x minus b factor. So up here, the x minus 2, the 0 at x equals 2 has multiplicity 3. Here the 0 at x equals 2 had multiplicity 2. Now, if you have multiplicity 2, what happens? It acts like a parabola, which is just a transformation of the x squared function. If multiplicity was 3, I at least claimed it, and by analogy you should pretty much be able to understand it, it's going to act like a transformation of the x cubed function. Okay? So on the graph, the point B0, that's one of your zeros, that's one of the points in your x-axis. It acts like a transformation of the y equals x to the p function as that function appears at the 0, 0 point. Just means we take the 0, 0 point of x to the p, we do a stretch, and then we do a translation, and that point becomes the point B0. And the graph then looks like that. Okay. Now, the other thing we need to be able to do, of course, we see what to do if the function has been factored. At least we've seen most of what to do. There's a little more to it. We see what to do if the function has been factored, but we have to know how to get, the polynomial is often given like something like this. It's not factored. What do you do with that? Well, that's what we're going to see next.